Jai Hind. Today we will discuss about the optimization problem, that is a part of the design and analysis of algorithm. What is the meaning of optimization problems? Here we discuss about the optimization. Basically, the optimizations problems is related to the finding a maximum and minimum for a given inputs of a given problems. Now we discuss the optimization problems. To solve the problem with the help of optimizations is a maximum. We find a maximum and minimum value is a for a given problem or for a given as a inputs for n inputs. The result is a maximum of minimum. It's known as the optimization problems. We have two techniques to optimize the problems. First is a greedy and second one is a dynamic programming. First one is greedy and second is a dynamic programming. Now we discuss about the greedy techniques, and after that we discuss about the dynamic programmings. Now come to the greedy techniques. What is the meaning of greedy techniques? We just discuss about the problem statement of a greedy techniques to solve the problems. Most of the problems in a greedy contain n inputs, and our objectives is to finding the subset of as a in outputs which will satisfy our conditions and optimize our goals. That's known as a greedy technique. Same as applied to the optimization. What we're talking about the optimization is we finding the maximum minimum with apply the conditions. It's known as a or the greedy techniques. When using the greedy techniques, always select the options that appear to be the best fit at the time. It's make it locally optimized decision, hoping a globally optimized solutions will follow the basic keys terms. First is solution space, feasible solutions and optimal solutions. In a greedy methods, we find in the set of a solutions space, and second we find to the feasible solutions, and finally we obtain a optimum solutions for a given problem. Just take some example. We discuss about to the working process of a greedy methods. We just take an example. We just find a top 10 students in a given a class, have a total number of students 150 students in a class students. We finding to the top 10 student. Find top 10 students out of 150. Here we have a solution space. Now we have a solution space. There is a solution space. How many number of a solution space? Combination is of 150 C 10. That is a total solution space. And we just, that's not a feasible solution. It says so many possible solutions. Combinations are there. We finding the feasible solution. The feasible solution is that's a solution space. Solution space. And feasible solution is we just obtain the feasible solution after apply the condition. Condition is given. We just obtain a marks more than 85%. 85%. More marks. Now it's reduce the solution space, and feasible solution is just assume it is a 80% of students out of 150 is 50 students obtain the 80 marks, more than 80 marks in a 50 students. So it's reduce the solution space in a feasible solution is a 50. It's a 50. C 10. It's a feasible solution. You can obtain a feasible solution. After obtain the feasible solution, we optimize the problems. Now we optimize the problem. Optimal solution is out of 50 is just assume it. It's a 10 1, 10 2, 10 3, and so on 10 15. That is a feasible solution here. Now the optimum solution is same as only one student is top of 10 C1. That is a one feasible solution. That is a optimum solution out of 50 C10. That's a optimal solutions. That's a basic term we discuss. Now we discuss the method. That is a solution space or possible solution over the number of inputs. In the example, we discussed about the total number of inputs is 150 students. Next is feasible solution or solution which satisfy our condition. Condition is more than 80%. Greater than 80%. 80% marks of students obtain. That is a feasible solution. Third one is obtain. Optimal solution is given as our feasible solution that will be optimize our goals are known as a optimum solution. The optimum solution is 10C1. That is a greedy methods approach. Greedy method is basically based on a locally and reach to the global optimize. Globally optimize. It's known as a greedy. Now, advantage and disadvantage about to the greedy techniques. Advantages we talking about to the advantages is using greedy techniques is creating algorithms is very simple in comparison to the dynamic programming. It's easy to analyze the algorithms at a run times. It's a very fast algorithms. It's generate a fast output, but sometimes its result is not be correct. It's take a lot of effort to the grasp the correctness in these situations. It's hard to be explained why the algorithm is correct even when it has a right answer. The disadvantage is that we are just calculate the result or sometimes result is correct, but we are not confirm the it's a correct results. So that's the disadvantages. Most of the times greedy is not give a correct answer, but dynamic programmers always give a correct answer. We are talking about the application of greedy techniques. Is first application is knapsack problems. Knapsack problems is basically we are just taking a bag and put the item in a bag according to the profit. We discuss in after that knapsack problems. Second is based on a job sequencing with deadlines. We have given a jobs with a deadline times. Next is a half-man coding. Next is optimum emerge pattern we discuss. Minimum cost spanning tree. There is a two type of algorithm based on a minimum cost spanning tree is a Prism algorithms, Kuskal algorithms, and single source shortest path algorithm based on a Bellman-Ford algorithms. Next is a Dicastra and Bellman-Ford algorithms. And breadth first traverser. Our pair shortest path is based on a fraud Varshini algorithms. First, now we discuss about the knapsack problems algorithms. It's a greedy approach. Problem statement. First, we discuss about the problem statement. Second, we discuss about the scenario. First is knapsack problem statements. Given a set of items, each with a weight and profit, we need to determine the subset of item to include the knapsack so that the total capacity of a knapsack will given the maximum profit. Our objective is obtain a maximum profit. It's our objectives for a given inputs. The inputs is given as a profit and with associated with weight. There is a different items. There is a object 1, object 2, object 3, and so on, object n. That is a n inputs objects. We just take a profit for a objects. We take into objects just a object 1, object 2, object 3, and object n. We just obtain. In a knapsack algorithms is based on a fractional. We just take in a fraction. First off, condition is given as we are taking the whole item, maybe no item, taking no item, or taking fractional. fractional item. That is an x of I belongs to. Okay, now we discuss about the scenario to better understand the knapsack algorithms. First, we just take a scenario. We create a scenario. A thief is robbing a store and can carry a maximum weight of WI in his knapsack. Knapsack is basically a bag. There are items available in the store. There is n items, just taking a 1, 2, 3 and 4, 5, 6 items as inputs, and the weight of the items is given as WI, and the profit of an item is given as PI. Next is what item should a thief take a maximum profit. We just find the maximum profit to carry the item with taken, not taken, and taken with fractional items. Now, to solve with the data understand, we discuss about to the example. Now, here problem statement is given as a. Now, here we are taking the 4 object, object 1, object 2, and object 3. There is a 3 items, there is a 3 objects, and capacity of a knapsack bag is 20 kg in terms of 20 kg. Okay. Now, first case we discuss about to taking profit. According to the profit, we just sort the objects in increasing order of profit. The increasing order of profit is first object 1, profit is 25. Next object 2, profit is 24. Next object 3, profit is 15. That is a increasing order. That is a sort the object in a profit to increasing order. Now, weight is corresponding weight is associated with item 18, 15, and 10. Now, first case we discuss about to the according to the taking profit. Now we just take it. That is a knapsack bag. Total capacity of the knapsack bag is 20 kg. Now, first increasing, first higher profit is 25 is higher profit. We just take a object 1. Now here we just object 1. We taking object 1. Object 1. Its weight is 18. 18 is less than 20. We just complete object will be taken in a knapsack bag. Complete object, that is a 1 taken, object 1 taken with profit equal to 25. Okay, next the remaining capacity is 20 minus 18. The remaining capacity is 2. Now capacity is 22 kg. Okay. Now second item is profit is 25. Now we taking a fractional part. Profit equal to 24. We are taking an object, next higher object, next is object is 24 is profit. Object 2. We take an object 2. Weight is 15. Now remaining weight is 2 and weight is given a weight is 15. The capacity or remaining capacity, we just calculate the next capacity is M is a remaining capacity of bag, knapsack bag upon weight of a object, weight of items taken. Remaining capacity is 2 upon 15. That is a fractional part. Fractional object will be taken 2 by 15. It's complete. Now, what about the object 3? Object 3 is not taken. Object 3 not taken. Say complete the bag. Now we calculate the total profit. Total profit is given as, observe it, total profit fit. First we take in object 1. Object 1 completely taken. 1 profit is 25 plus object 2 we are taking as a fractional part, 2 by 15 into profit is 24. Total profit is, we just taking a object 1, whole object 1 is taken, 1 into profit is 25 plus next object 2 taken but in a fractional part, 2 by 15, profit is 24 plus object 3 is not taken, is 0 into profit is 15, not taken. It's a not taken. The total profit is given as, just observe it, total profit is, calculate the value is 28.2. Solve this. Now that's it, one case is completed. Now we check the according to the weight taken. Now according to the weight, we just take a weight in a decreasing order. We just take a less weight. First we take in item object in a decreasing order weight in a bag. Maximum weight we carry, so we just put a small weight in a bag. First small weight is object 3. Second small weight is object 2 and object 1 according to the weight and profit. We just check the weight. Small weight is object 3 we taken. First we taken a object 3, next we taken object 2 and last we taken object 1. Weight is 10. Weight is 10 and profit is 15. Object 3. Object 2 weight is 15 and profit is 24. Object 1 weight is 18 and profit is 25. Now we just same as we taking a bag. Total capacity of the bag is 20 kg. Now first we take an object according to the minimum weight is 10. We just choose the object 3. Object 3. Okay. Weight is 15. Profit is 15. Weight is 10. The remaining weight is 20 minus 10. Remaining weight is M dash equal to M minus W. Weight and 20 minus 10 is 10. It's a 10 weight, 10 kg. Okay. Now next is object. We take in the object 2, but its required weight is 15, but remaining weight is 10. We just take a fractional part of this object, not a complete object. We just take a fractional part in object 2. Now we're taking the object 2. So next is remaining weight is 10. Weight of the object 2 is 15 and profit equal to 24. Okay, that's a complete. There is a no remaining weight. So object 1 is not taken. Okay, now we just compute the total profit is total profit. Now compute the total profit is object 3 is taken complete, or object 3 is completed. 1 into profit is 15 plus object 2, it's taken as a fractional part, 10 by 15 into 24 profit, plus object 1 is not taken, 0 into profit is 25. The total profit is computed as a 31. Just solve this for 15 plus 240 divided by 15 plus 0. To solve it, answer is 31. Now, in the previous, if we are taking the according to the weight, total profit is a 28, and if we taking the weight, profit is 31. Now we taking the profit per weight. Next we discuss the next profit per weight in the next class. Okay, thank you.